Okay, doing this the super low tech way again. There's a shock. Thinking of doing a new series, just things that strike me in the course of the day as being difficult to explain using the flat Earth model that make perfect sense in the round Earth model of the world, particularly with regards to my thought of a simple flat Earth model. The simple one being just the Earth is flat, the sky is also flat, and a few hundred miles above the surface of the Earth. Or maybe that the Earth is flat and the sky is a dome, just a few hundred miles above the surface of the Earth. Anyway, not saying that the Earth isn't flat, really, but there are some things that show up as being just a little odd and difficult to explain in that model. One of them that struck me the other night, the planet Mars, which is currently coming into opposition. It is very obviously much brighter in the sky right now than it has been in years. And it is exactly opposite the sun in the sky, in the sense that when the sun is setting, Mars is rising. When the sun is rising, Mars is setting. And presumably when Mars is at its highest point above the horizon, the sun, well, it basically occurs right at midnight, at the point when the sun would be as far away from me as it possibly can be on a flat Earth, or on the opposites, shining over the opposite side of the planet on a spherical Earth. All of which makes perfect sense in a heliocentric round Earth version of reality. Right now, Mars and the Earth are on the same side of the sun. Therefore, the two orbits are such that the Earth and Mars are basically passing each other on the little race course of their orbits, and therefore they're very close together. And also, the sun is exactly the opposite direction from Mars. It's very difficult to explain why this coincidence would happen like this in a flat Earth model. Not saying it's impossible, it's just a little bit strange. This happens not only with Mars, but also noticeably with Jupiter and Saturn, all the superior planets. It also happens to some extent with Uranus and Neptune and Pluto, but those are difficult to see without a telescope. In fact, they're, other than Uranus, basically impossible to see without a telescope. All of them get brighter when they are exactly opposite the sun. And if you get out a telescope, and you can observe the change in brightness just with your naked eyes. And if you get out a telescope, you can also observe that Mars physically looks bigger in the telescope. Right now, it's about 5 times the diameter that it would appear when it's at its greatest distance from us. This suggests that any model you come up with for the orbit of Mars is going to have to include the fact that sometimes it's 5 times closer to us than it is at other times. Or I suppose you could come up with some explanation that Mars isn't actually getting closer and further away, it's shrinking and growing. But anyway, just a little observation about the way that Mars appears in the sky right now. Very bright and exactly opposite the sun. Really easy to explain that in a heliocentric spherical Earth model. Really kind of a bizarre coincidence in a flat Earth model. Not to say again that the flat Earth model isn't right. It's just really hard to explain what Mars is doing right now in that model. Thanks. Have fun.